So, okay, the system has 4.5 times 10 to the second kilocalories of work done to it and releases 5 times 10 to the second kilojoules of heat into its surroundings. What is the change in internal energy of the system? So when you do work to a system, does it increase or decrease the internal energy?
So you're doing work to the system?
I'm just asking you, if you do work to the system, does it increase or decrease?
It increase.
It would increase, right?
Yeah.
So
So if the system doesn't work, that's when it's letting it out. Correct?
Mhm.
Okay.
So this is saying if a system has X amount of work done to it and it releases X amount of heat into its surroundings. So it's like work is being done to it and it's releasing heat.
Okay. And it's releasing more than it's gaining. Because it's releasing 5 times 10 to the second. Well, that's kilojoules.
Right.
Kilocalories, so I guess we'll have to see.
We'll have to do the conversion to really measure, but yeah. So yeah, there's our conversion factor. Okay.
So we got 4.50 times 10 to the second.
Let's see if we can give them something to make a video out of.
Yeah. Put that up here.
Okay. If you don't mind reading to me what it says, and we can
Okay.
try to.
So if a system has 4.50 times 10 to the second kilocalories of work done to it,
Okay.
and then 5.00 times 10 to the second kilojoules.
5.00
Yeah.
times 10 to the second kilojoules.
Of heat is released into the surroundings.
Let's do a triangle for heat.
Yeah.
Is released, and then it says what is the
What is the change in internal energy?
Okay. So, and what we were just talking about before is when you read it at first, it's like, oh no, where do you start?
Yeah.
But it's saying it's just saying X amount of work is done to the system. If you do work on the system, you increase the potential energy.
Mm-hmm.
And then X amount of heat is released from the system, which is kind of like saying X amount of work was done by the system, in a way.
Yeah.
Which that decreases the internal potential energy. So then what is the change? Like what's the net effect? It's kind of like if you find 20 bucks on the ground and then you go spend 50 bucks, what's the net effect on your bank account? Minus 30, you know what I mean? So let's find out, did this lose or gain
Okay.
net energy? Okay, and there's a conversion factor that they gave you in the problem, right?
Yeah.
So how do we go from a kilocalorie to a kilojoule?
For every kilocalorie, there's 4.184 kilojoules.
Sorry, one point.
That it'd be 4.184 kilojoules.
4.184. 4.184. Sorry, my brain is going on. 4.184 kilojoules, and then you said that's
1
per
kilocalorie.
1 kilocalorie.
Yeah.
Okay, so kilocalories cancels. Oh, sorry, we had how many?
4.5.
We had
Well,
4.5.
450 really.
Just 10 to the second, good, okay. So what would this come out to be?
1,882.8.
882.8
Yeah.
kilojoules.
Mm-hmm.
Okay, so now, I don't know if it was me, I would almost just do this. Just erase what it tells you in terms of kilocalories. Write in the problem what you just, your conversion, so 1,888, or 1,882.8 kilojoules. So now if we read it, 1,882.8 kilojoules of work is done to a system, and then another way to write that would be
500 kilojoules
good.
of heat is released.
500 kilojoules heat is released. Okay, well it looks like there was a net gain, right?
Yeah.
So we know our answer should be positive and
1382.8.
1382, and that's a net gain, right,
Mm-hmm.
of energy.
And
Does that
that's
make
it?
sense? That's, yeah.
Wow.
Yeah, because it's asking you for the change in energy, so like change in is delta. So change in energy would equal a net gain of 1,382.8 kilojoules.
Yep.
Cool.
Wow. We were overthinking that way too much.
I know, it's
Yeah,
hard.
that does make sense.
When you see these kind of problems, it is really hard to just get lost in all the, even though it's not that many words, but in all the words. It's like,
Yeah.
oh no, this, then this.
This is being done, this is being released, like.
Yeah. Seems like the challenge with some chemistry problems isn't the fact that it's like if they had asked you just the first half of the question or the last half of the question, no big deal. But if they combine two things, all of a sudden it's so much harder.
Yeah.
You just have to take the time to weed through it and see, oh, there's just two little pieces, and once you put them together, it's no big deal at all. So.